In the last unit, we studied the properties of quadrilaterals. In this unit, we're going to see if we're given a quadrilateral, a figure with four sides, what information do I need so that I can conclude and prove that the given quadrilateral is a parallelogram? So let's take a look here. We have two theorems. The first one says if both pairs of opposite sides of a quadrilateral are congruent, and I want you to pay attention, is the opposite sides are congruent, then the quadrilateral is a parallelogram. So in this case, if both PQ and RS are congruent and QR and PS are congruent, then I've got a we've got a parallelogram in PQRS. Okay? Now this theorem says if both pairs, it has to be both pairs of the opposite angles of a quadrilateral are congruent, those are the keywords, then this time again, my quadrilateral is a parallelogram. So either both pairs of sides are congruent or both pairs of angles are congruent. So see how they drew the tick mark? Opposite angles, both pairs are congruent. Therefore, right there, I have a quadrilateral. I have a parallelogram. So here's a follow-up. It's also a review. Remember the concept of converse. When we talk about converse, we usually have a if A happens, then we can draw conclusions about B. So a converse is just you switch the hypothesis, which is in this case is A, with a conclusion. So here's the converse. The converse statement would be if B happens, then A, right? So if we have to write the converse of this first theorem on top, the conclusion, go for the B. The if is in the here. The conclusion is after the then. So if I have a parallelogram, then what happens? Then both pairs of opposite sides are congruent, right? So that's how we write a converse, but see the relationship between the original statement and its converse, and make sure that you finish the second part of this page. Now let's look at the second page. We have an example here. It says, tell whether the quadrilateral is a parallelogram and explain. The first one, the answer is a no, because I have two pairs, right? I have both pairs, it satisfies that, but however, both pairs, it satisfies that. However, these two pairs are not the opposite sides. So therefore the conclusion is no, this is not a parallelogram because they are the opposite sides are not congruent. It has to be not only two pairs but also opposite sides. And the second one, as you can tell, 40 and 40, 140 and 140. So yes, this one fits the criteria of the theorem that we just studied because they are, it's a parallelogram because both pairs of opposite angles are congruent. Okay, now next theorem, we have a couple of more theorems here. Most of these, if you understand what parallelogram is, most of these theorems are very, very intuitive. Here it says, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So in this example here, look at if P, angle P and angle Q, right? They add up to 180 degrees, the yellow angle and the green angle. Because opposite sides are congruent, so the opposite sides are also, this one is also a yellow angle, and this one is a green angle. So if angle P and angle Q is a pair of yellow and green, that adds up to 120. Angle Q and angle R is green and yellow together, that also adds up to 120. And for the same reason, angle R and angle S also adds up to 120. Angle S and angle Q also adds up to 120, 180. Can't speak this morning. So that, now let's go back and review this. If an angle of a quadrilateral is supplementary to both of its consecutive angles, so if this yellow angle Q is supplementary to both of its consecutive, it's right next to it, right? Then we've got a parallelogram. If this angle R is consecutive to both of its consecutive, same side interior, consecutive angles, that's what it means, then we've got a parallelogram here. Last theorem, if the diagonals, remember what happens to the diagonals if I have a parallelogram? If the diagonals of a quadrilateral bisects each other, then this is also a parallelogram. So in other words, if QM is congruent to MS, PM is congruent to MR, then I've got a PQRS, a parallelogram. So finish writing the converse of these two theorems and see if you can make a connection to the properties that we learned in the last unit. Now, let's look at this example here. Tell whether this is a this quadrilateral is a parallelogram. The first one, let's look at it. We said this is a green angle and this is a yellow angle, right? And if this is the yellow angle, because this is a I don't know what this angle is. See, what is this angle? So I have to do a little bit of calculation. Notice that any quadrilateral, the interior angles adds up to 360. So if I use 360 minus 95 minus 85 and minus 85 again, because there are two 85 degrees and one 95 degrees. And I think our answer is 95 degrees. Therefore, this one is also 95 degrees, which means these two are congruent, right? And because of that, I can draw the conclusion that this is a parallelogram, because angle T is supplementary to angle U and angle W. Okay, the second one is not, because look at the diagonals. None of them, these two are congruent, but it doesn't bisect each other, right? So parallelogram, the diagonal have to bisect each other. So you can just say because the diagonals do not bisect each other. Okay, so that's the last theorem in this unit, and see if you can finish these checkpoints without my guidance. And if you have any questions, let's discuss it in class. And also remember to complete your IXL practices. All right, guys, thank you. See you in class.